Today's video is all about segments. I'll be covering three major ideas about segments: the ruler postulate, the segment addition postulate, and finally midpoints. First, let's review segments. I'm given segment AC, and this is how I would label it, with a segment sign above it. Let's look a little deeper. Let's add coordinates with them. We can signify those with lowercase a, lowercase b, and lowercase c, and any other letter you'd like to use. We can put coordinates on any segment just like a ruler does. Now, how long is segment AB? How long is segment BC? How long is segment AC? Hopefully, you got these answers. If you just counted them, that's fine, but just in case, here's a nice little helper equation. Take the coordinates and subtract them, and make sure you take out the absolute value of the answer. Here I have shown how to find segment AC two different ways, and notice that each time I got 16, no matter the order I started with. What do you notice about segments AB, BC, and AC? I notice that 4 plus 12 equals 16, which leads me to our next topic. Now that we know how to find lengths of segments, let's look at segment AC without coordinates, but with lengths. What is the length of segment AC? 2 plus 7 equals 9, is what I'm hoping you got. I like to think of the segment addition postulate as this little guy added to this little guy will give me the great big guy. Let's apply these little guys with algebraic expressions instead of simple numbers. Notice that EG is made up of segments EF and FG. So I've altered the original formula from the segment addition postulate using these points. I have substituted in the expressions from above. I'm going to add them together and set them equal to 59, which was my EG from the directions. Remember that when we solve equations, we first need to simplify each side of the equation before moving terms from side to side. So, I noticed that 8x and 4x are like terms, so I'll combine them for 12x. Notice that negative 14 and 1 are like terms, so I combine them for negative 13. Next, the 59 is lonely, is what I call him, and so he needs a friend. Negative 13 would like to come play. So we add him to the other side, and we get 12x equals 72, and divide by 12 to get 6. Always go back to the question to make sure you have answered it. Are we looking for x? No, we're looking for EF and FG. So we're going to plug this 6 back in for the variable for each of EF and FG. And you'll notice that as I did that, I can plug it right back in and notice that 34 plus 25 is 59. Our last topic today is midpoints. I will start with introducing the differences in when to use the segment addition postulate and midterms. If I say that B is a midpoint of this figure, what does that mean for this figure? How can I show that? In math, we can use tick marks to show that two segments are congruent or that a point is a midpoint. Notice that if I change this, even though I didn't change where B was, I now say that B is not a midpoint just because the tick marks. And now it's back to being a midpoint. Let's use it now. Notice that segment AB is congruent to segment BC, and therefore the lengths of AB are congruent to AC. make sure that you understand the figures are congruent and their lengths are equal. Back to talking about midpoints. Since B is a midpoint, then the length of AB is equal to the length of BC. Here is an example of how we can use midpoints. Given segment given segment PR and Q is the midpoint, notice that I now can put tick marks on PQ and QR since I know that Q is a midpoint. I know that segment PQ is congruent to segment QR, and I also know that the lengths are equal. So what I'm going to do is bring down these lengths right here and set them equal to each other. Now both sides are simplified, so I'm going to bring this 5x over to here, and then I'm going to get rid of the minus 7 by adding it to the other side, and that will give me an x of 8. But again, we're not looking for x. We're looking for PQ and QR. So we're going to plug those back in and find out that our answers are 41, which they are indeed congruent and equal. Notice that we were only given 2 pieces of information in this problem and not 3 like we did in segment addition postulate. So that should be a clue that we're going to need to use that Q is a midpoint to set them equal to each other.